All right, so I wanted to go over a couple of things that relate to polynomial graphs. I think people walked away from the last class with a better understanding of how the graph relates to the function, but also not knowing exactly what we were supposed to know from the lesson itself, and that's fair. So I have three different pictures of polynomial graphs, and I think if we're at the point where you can look at the graph and write the function, that's a pretty good spot to be at, but it's going to take a couple rounds of practice to get there. So for each one of these things, there's two things I want to know right off the bat. Number one, I want to know is whether the leading coefficient is positive or negative, and I also want to know whether the degree is odd or even. Okay, so the thing I would say is that the degree is even if both of the arms point in the same direction. It's odd if one arm points up and the other arm points down. Okay, so in the first case, this is a even degree. In this second case, this is going to be an odd degree. And in this third case, the left arm is pointing up, the right arm is pointing down. So this one's also going to be odd. Okay, so the leading coefficient is either positive or negative. It's positive. I'm only going to be looking at the right arm. So if the right arm is pointing up, the leading coefficient is positive. If the right arm is pointing down, the leading coefficient is negative. If the right arm is pointing down, the leading coefficient is negative. Okay, and so then a lot of times you can figure out what is the degree, and you can't always count on this rule working, but you can a lot of times expect that the degree, if I count the number of turning points, see this has three different turning points, 1, 2, 3, local minimums or maximums, and the degree oftentimes is going to be one more than that number of turning points. In all these examples, the degree is one more. So in this case, there's two turning points, so the degree is 3. In this case, I have 1, 2, 3, 4 turning points, and the degree is going to be 5. All right, you don't always have to know what the degree is to write the function out, but I'm just showing you all the different things that you can infer from looking at these things. What I can say is that the degree is at least 4. It's possible that the degree could be larger than 4 in the case that there's 3 humps, but it could never be less than 4. All right, and then the other thing I want to look at is I want to know what are these x-intercepts. So there's -3, there's a 2, and this is a 5, which means if I'm writing my function out, it's going to be y is equal to a times x minus 3. No, not x minus 3. X plus 3. And I'm also going to have an x minus 2. And I'm also going to have an x minus 5 in there. Now, one thing that you should know is that when the function has an x-intercept where it just crosses over the x-axis like this does at 2 and 5, that means I'm going to have the factors raised to their normal power of 1. However, when I have a factor like this has at -3, notice how it's not crossing, it's not going from the positive into the negative, it goes from the positive, then it hits the x-axis and it goes back into the positive region on the y-axis. When I have a function that looks like this, when I have an x-intercept that touches and turns on the x-axis, when I have an x-intercept that is also a local minimum or a maximum, that means that that factor, this is when x is equal to -3, that's this factor right here, it means that factor is squared. So now I know that my function is y is equal to a times x plus 3, x minus 2, x minus 5, x plus 3 is squared. The only thing that I'm missing now is this a value right here. And the way I'm going to get this a value is by plugging in this, I'm going to use this locator point. So the locator point here is 0, 45. And so if I put in 0 for x, I should get 45 for y. So 45 times 3 squared times negative 2 times negative 5. If I look at, what is this, 45 times 9 times 10, that's 90a. Well, that means a is equal to 45 over 90, which is 1/2. So in this case, my final answer is going to be y is equal to 1/2 times x plus 3 squared times x minus 2 times x minus 5. Boom. All right. Next example. It's a degree of 3. It looks like I have x-intercepts at -1, at 0, and at 2, which means I have this function y is equal to a times x plus 1 times x minus 0 times x minus 2. Well, you should know that you're never going to, in reality, see x minus 0. It's just going to look like x plus 1 times x minus 2. And so now I need to figure out a point where I can plug in the number and figure out what the y value is. And you might think, all right, well, I'm going to look for the point. This point is 0, 0. But if I plug 0 in for x, because there will be a 0 here, no matter what a is, I'm going to get 0 for y. So when the function has an x-intercept that's at the origin, then I actually have to look for another point, a point that's somewhere not on the x-axis. And look at this. I've got a point. And I can figure out that that point looks to me like it's -2, 2, which means when I plug in -2 for x, I should get 2 for y. So when I do -2 plus 1, I get -1. When I do -2 minus 0, I get -2. When I do -2 minus 2, I get -4. When I multiply all those three things together, I get -8a. So 2 is equal to -8a, which means a is equal to -1/4, which means if I'm writing this equation, it's going to be y is equal to -1/4 times x plus 1 times x minus 2. Okay, ready for the last one? All right, so in the last one, what do we got? We have -1, we have 3, and we have 5. If you're looking at this, you should be able to say that this is y is equal to a times x plus 1 squared. And it's squared because there is the turning point there, times x minus 3 squared. And it's squared because there is the turning point there. And it's going to be times x minus 5, and that's only one of them. Then it looks like I'm going to use the point 11.25 is equal to a times 1 squared times -3 squared times -5, which means 11.25 is equal to a times 9 times 5, which is 45. So a is equal to, sorry, that's going to be negative 11.25 divided by 45, which is, 11.25 divided by 45 is 1/4. Okay, so this is going to be y is equal to -1/4 times x plus 1 squared times x minus 3 squared times x minus 5. There you go. That's what you should know.